Welcome. In this short lecture video, we are going to discuss about how to use gamma functions to evaluate a certain integral. So this is a problem. To use the techniques of gamma function to evaluate, to show that this integral is given by 15 over 2048 root pi. So to solve this one, you have to first remember that gamma of x is given by gamma of function x is from 0 to infinity integral t raised power x minus 1 e raised power minus t dt, where this x must be a positive real number. And then just another thing that you need to remember, that gamma of a half is given by root pi. So because the integral we have doesn't take this form, we'll be required to fix it or to transform it in another variable so that it has the same standard form as gamma function. So we do that one by letting u to be this part for x squared. And indeed, this transformation will work because as x approaches 0, then still u will approach 0. Because when you put 0 here, then 4 times 0 is 0. So still u approaches 0. And then as x approaches infinity, as we have here, then still u approaches infinity, because 4 times infinity squared is still infinity. So therefore, the limits actually agree. So the next thing now, from this one, it tells you that x squared alone will be u over 4, which tells you that x alone will be u over 4 square root, which will be u power half divided by 2. Now, from this one, we can get the u to be 8x dx, which tells us that dx will be du over 8x. So then the integral 0 to infinity x power 6 e raised power minus 4x squared du dx is the same as integral 0 to infinity x power 6 and then e raised power minus u, because we have already fixed this part to be u, and then dx is du over 8x. Now, this will give us integral from 0 to infinity. So I factor out 1 over 8, which is at this point here. And then using loss of indices, x power 6 divided by x power 1 will give me x power 5, e raised power minus u du. But I know that I can always express x in terms of u using this transformation. So I'll have, remember this 5 is power for x, this e raised power minus u. So I'll have u raised power half divided by 2, so that the place of x, u raised power 5, multiplied by e raised power minus u du. So that will give you so I factor out, so I have 1 over 8, but there is also 1 over 2 raised power 5 here, and then integral 0 to infinity of u raised power 5 over 2 e raised power minus u du. So 2 raised power 5 is 32. When you multiply by 8, you get 256. So I have 1 over 256 integral from 0 to infinity u raised power 5 over 2 e raised power minus u du. So this will be 1 over 256 0 to infinity of u. So I can write this one as 7 over 2 minus 1, and then e raised power minus u du. I'm doing this one because I know that gamma of a function x is 0 to infinity t raised power x minus 1 e raised power minus t dt. So that's why I'm writing this form. So therefore, it's very easy to know that our x for this case here is 7 over 2. So therefore, it's like I have 1 over 256 gamma of 7 over 2. So you write this one as 1 over 256. All this integral is in the standard form of gamma of 7 over 2. But we know that gamma of x plus 1 is the same as gamma of x, x gamma of x. So which tells us that gamma of 7 over 2 can be written as gamma of 5 over 2 plus 1. So which will be 5 over 2 gamma of 5 over 2. And then gamma of 5 over 2, the same as gamma of 3 over 2 plus 1, which will be 3 over 2 gamma of 3 over 2. And then gamma of 3 over 2 is nothing but gamma of a half plus 1, which will be a half gamma of a half. And we know gamma of a half is root pi. So therefore, this is the same as 3 over 2 times a half root pi. And therefore, this will be 5 over 2 times 3 over 2 times a half root pi, which will give us 15 over 8 square root of pi. Therefore, because this is what we need to have as our solution, we just have 1 over 256 times 15 over 8 root pi, and 256 times 8 gives you 2048. So therefore, this is the same as 15 over 2048 square root of pi. And this is what we are supposed to prove. So that is how you get the answer to that given problem. Thank you.